Welcome to solverfy.
Question 106 is a buffer solution calculation. We have a desired target pH of 7.00. We are preparing this buffer by mixing potassium hydrogen phosphate and potassium dihydrogen phosphate. We recognize that the acid in this buffer is going to be the potassium dihydrogen phosphate, and it has a Ka value which we can look up at 6.3 times 10 to the negative 8. Because the buffer pH is independent of concentration, I am going to choose a total volume of 1 liter and then modify the calculation at the end. Actually, I apologize. I'm going to choose 1 molar concentration. Doesn't matter what the molarity is, the pH of a buffer solution is independent of molarity, but choosing 1 molar will make the calculations easier. So the pH of my buffer solution, target pH of 7, will be equal to the pKa, the negative log of the Ka value for the weak acid in the buffer, multiplied by the moles of the base I have in the buffer divided by the moles of the acid I have in the buffer. So if I want a solution, if I am using a solution of potassium hydrogen phosphate, which is my base, that has a 1 molar concentration, then I can determine the moles of that weak base that I have by multiplying by the volume that I added in order to create the buffer, which I don't know, which is X. Then I can calculate the moles of weak acid, the dihydrogen phosphate, by assuming I have a 1 molar solution of dihydrogen phosphate. And I want to prepare a total volume of 100 milliliters or 0.1 liters. So if this X is the volume of the base I need to add, then I need to add 0.1 minus X of the volume of the acid, so that when combined I have a total volume of 0.1 liters or 100 milliliters. Then I can do my algebra. The negative log of 6.3 times 10 to the negative 8 is 7.200. I'll then subtract that from both sides to get the negative 0.2, and then I still have my log expression on the right hand side. I'll do the anti-log of both sides to get rid of this log term. 10 to the negative 0.2 is 0.630. I'll then multiply both sides by this denominator, and I get this expression with just x on the right hand side. I then collect my like terms and divide by 1.63 in order to isolate my x, and I get an x of 0.03865. That again is the volume in liters of the base. To calculate the volume in liters of the acid, I simply need to subtract it from the target volume of 100 milliliters or 0.1 liters, and I get 0.06135 liters of the acid.